Welcome back. In the last video, we defined the arctangent function. Now in example 1.2.6, we'll give the graph of the arctangent function, and then we'll talk about its domain and its range. All right, so when we define the arctangent function, we restricted tan to be between minus pi on 2 and pi on 2. And so we had these two vertical asymptotes here. And the part of the graph that we looked at was this part here. It goes through 0, 0 and skims the other asymptote. All right, when I flip the role of x and y to get arctan instead of tan, so this one is arc equals tan of x for x in minus pi on 2, pi on 2. All right, when I flip x and y, then instead of having vertical asymptotes, I'm going to get horizontal ones. So here y will be minus pi on 2, and then here y is pi on 2. These will be my horizontal asymptote. 0, 0 will stay 0, 0, so that point is still on my graph. And then I'm going to skim one, get through 0, 0, and then skim the other asymptote. So this is the graph of the arctan. Let me just say you're responsible for knowing this graph and the graph of arcsine as well, and you're responsible for knowing the domain and the range. So this is more than an example. It's actually something that you need to learn. All right, I'm going to give the domain and the range of the arctan function. For the domain, it's every x value where we have a graph. So here, if you notice, every single point on this axis corresponds to a value, and so the domain of arctangent is all of R. All right, so that's a nice function, a function that's always defined. That's nice. If I look at this graph here and I'm asking for its range, I notice that I start at the horizontal asymptote and go to the other one, but I don't include the endpoints. And so the range of arctan of x is, so I'm going to start at minus pi on 2 to pi on 2. And of course, I'm going to exclude them because they're not attained in the graph. And so I'm going to put these round parentheses that we use for excluding now. All right. So let me recap how you define arctan. I'll give you the definition again, but in more spelled out way, and then I'll give you a method like we had for arcsine. From the definition and from what we learned in section 1.1, we know that if I have arctan of x equals theta, that means I have x equals, so if I send arctan to the other side, I get tan. So I need tan of theta to be x. So when I ask you for arctan of x, I'm giving you the value of tan, and you need to give me the angle, and you're only allowed to use angles between minus pi on 2 and pi on 2. All right, so note that when we ask you for arctan of x, then we're giving you the tangent value, that's x, and we're asking you for the corresponding angle. Remember that a tangent corresponds to, it's y over x, and so really it's the slope. All right, slope 0 means flat line, slope 1 means 45 degrees. That's the type of slope I mean. All right, so find theta so that method to evaluate arctan of x. Step 1, find theta so that tan theta is absolute value of x. So just like before, positive values are easier because we have our little table, and you find tan theta in this little table. So whatever x is, you look for absolute value of x in this one, and you'll get the corresponding theta here. If x is positive, then the value you found is the correct one, and you just put it in. If x is negative, then instead of having positive slope here, you want the negative slope, and so you're going to get minus theta. All right, so this is very close to the way we did arcsine. It's just that instead of using the sine row of our table, you're going to use the tangent. All right, so I want to do examples using this table because for arcsine I started with doing examples from the trig circle, and I want to make sure that you guys understand how to use this table. All right, so let's start example 1.2.7. I want to evaluate the following expression. So I want to evaluate arctan of root 3. So that means that my x is root 3 and absolute value of x is root 3 as well. So in my table, I'm looking for root 3 in the tan column, right? And I'm going to return the theta from above. So from the table, I get that. Theta is pi on 3. All right, perfect. So if I'm asked for arctan of root 3, it's positive, x is positive, and so I don't change anything. I just get pi on 3. All right, so the root 3 I gave you, that was the tan value, and you had to come up with the angle. Let's try one with a negative, just to show you the difference. Here, x is -1. I will look for its absolute value in the table. So I'm looking for 1. And if I go back, 1 is with pi on 4. So right above, I have pi on 4. So from the table, I get that theta is pi on 4. All right, and that makes sense to me, right? If you have a slope of 1, the angle is 45 degrees, which is pi on 4. But I wanted a slope of -1, so that's not my answer. If I look back at the method, if x is negative, I need to flip the answer. And so instead of having pi on 4, arctan of -1 would be minus theta, which is minus pi on 4. So if you want a slope of -1, then you use the angle minus pi on 4. All right. All right, so that's it for this video. Come back next time.